Formulas. Thursday's the quiz. There will be 3 formulas on that. 2 you already know. Third one I'm gonna provide today. So let's first start with circumference formula for me. 13, Charlie's circumference formula. Pi d, what's that d stand for again? Diameter length. Good. So pi times the diameter, or we went over if anybody uses 2 pi r radius. R is the radius length. Length of an arc. How do I find the length of an arc? I'm going to use this formula again today with you. Length of an arc. How long an arc is. 9, how long is an arc? Measure of the arc, and that's in degrees, over 360 times pi d. Now, I want to just get a little more specific with this after yesterday's class. Yesterday we went over, all right, you can measure an angle in degrees or you can measure it in radians. This formula the angle has to be in degrees for you to use. All right, that's how you find the length of an arc if you know the angles in degrees. What if it's in radians? That's our new formula today. I'll show you in a few minutes. How do you find the measure of an arc? What do you look at? Measure of an arc's the same as what in a circle? So I got my circle. How many degrees is in this arc right here? It's the same as it's, talk to me, 11? Nope. 7? Central angle. Good. And remember, the central angle is located right here. All right, right there. So we're all good so far. Before I go, it looks like I'm going to vocabulary next. All right, let's go vocab. Circle K, let's stop right there. What do you already know about my circle? Forget about the vocab. 9, what do I know? What point? Thank you. Center is K. Tell me how to write radius KS. 8, how do I draw radius KS?
You go from the center to the circle, the out.
I got you. Tell me how to write diameter GH. Diameter GH. Talk to me. 10.
A line on each side of the circle, going each side going through the center.
That's the biggest point I'm looking for. It's got to go through the center. And then how about chord WV? Chord WV, how can I draw that? 13.
Start on one point on the outside of the circle, and it doesn't have to go through the center, but it can, and then it ends with another point.
Nice description. So there's a chord. Anything on the vocab yet? Last piece. Yesterday, how do I go from degrees to radians, radians to degrees? If you have to look on your formula sheet, that's fine too. You'll get the formula sheet. Remember, on Thursday's quiz, I will give you that sheet. So I have degrees and I want to go to radians. So for instance, I have 70 degrees and I want to turn it into radians. What am I going to have to multiply by? Okay, what's that conversion? What do I need to multiply the degrees by to get to radians? That conversion, 6. Pi over 180. Good. Nate kid wasn't even here yesterday either. Perfect. And we always like to leave it in terms of pi. All right. I don't want to see the long decimal on your calculator. Leave it in terms of pi. And then if I'm going in reverse, let's say I have 2 pi over 3 radians, and I want to go to degrees now. What do I end up multiplying by here? 9? 180 over pi. And then most times, about 95% of the time, the pi's will cancel. Sometimes they don't, though, if there is no pi in the radians. All right, that's where we are. Any questions on the assignment last night? I know most of you did it. Are we all right with the clock? In case a clock question comes up on Thursday's quiz. The biggest thing is, and I can't remember if I'm going to give it to you or not, but 1 minute, 6 degrees. Go, Charlie. Okay, you got it. So here's what I'm looking for. Give me the angle through which the hour hand, here's the hour hand right here on the clock, here's your hour hand, rotates from 1 p.m. to 9 p.m. So 1 p.m. to 9 p.m. I want to know this hour hand, how many degrees and then how many radians does it travel going from 1 to 9. And I gave you this little conversion here. Every time it goes a minute, a tick mark, it goes 6 degrees. So what I'm going to find is, all right, how many minutes does it go from 1 to 9? Minutes. You know, and we could stand here and keep counting, right? 1 minute, 2, 3, 4, 5, etc. Okay, going all the way around. How many of those do I go from 1 to 9? Anybody figure that out? How many minutes? Now I know it's 8 hours, but well, that's how I get to the degree. I'm talking how many tick marks, how many minutes? If I counted all these up here, does it go? 48. Does it go 48?
I think so.
48.
Oh wait, no, maybe it's 45.
Okay, how about this way? You're at 05 and then you go to 45. How many minutes is it going to go?
45.
40.
40.
40 minutes. Good try. We're going 40 minutes, right? If it's 105 and I go to 145, that's been 40 minutes. Everyone agrees? You good, Charlie? I know 40 minutes. So if it goes 40 minutes total and it goes 6 degrees every minute, I multiply that by 6 and that's how I get 240 degrees. So it's going to go 240. Good there. All right, now how many radians? Now I convert. 240 times, we just wrote it on the previous slide, but pi over 180. That's what I multiply degrees by to get to radians. I leave the pi in my answer, and I go to my calculator and do 240 over 180 to get that reduced on my calculator. And that what that reduced down to, everyone? 4/3. So 4 pi over 3 radians. Okay, so I just got to find out how many minutes I'm going and multiply that by 6. Everyone all good? We sure? Because I'll check for tomorrow, and I don't want to say confidently yet. I might have put another clock question on the quiz. All right, anything else converting? Am I doing anything different today? No, but I want to show you how to find the length of an arc if it's if the degrees in radians, and if the measures in radians instead of degrees. So we're all good here? All right, considering I saw most of you do this yesterday in class, so we should be good. All right, ready? Okay, here's today's topic. Let me make it clear again. Go back. I just don't want to do slide transitions and then it pops up. There we go. Hopefully we know this formula today. If not, we know it by Thursday's quiz. You can't use this formula unless that angle's in degrees. So what if it's in radians, right? If it's in radians, I can't use this formula. We're all clear, right? Because I got to put degrees in here for the measure of the arc. But what if my angle is in radians instead? That is a new formula I'm going to give you guys today, a third and final formula. First thing, I don't like teaching it. So I'm not going to start it that way. Can you get rid of that for me? I don't want to teach it that way. I want to teach it a much better way. So get rid of that little symbol there. It'll come back up. But all right, so how to find an arc length that's going to be in radians. Ready? S equals, I'm going to put this symbol here I'll talk about in a second. That's theta times r. This is how to find arc length again. Hey. Are we good here, guys? I can't keep stressing this enough, and this is why I get all intense. We know how to find the length of an arc. I gave you a formula on day 2. That formula right there, how to find the length of the arc. The problem is this formula only works if my central angle's in degree measure. All right, it's only in degrees, but we learned yesterday, sometimes an angle's not in degrees. It could be in radians. So if it is in radians, this is why I'm doing this today. I need to use this formula for arc length. S is your arc length. R is your radius length. And here you go. That symbol is theta. It's a Greek symbol. Theta. And what it is it's your central angle measure. But ready? In radians. All right, that's my central angle measure, but it's in radians. If it was in degrees, I got a formula for that. That was day 2. But if it's in radians, I'm going to use, some people call this SOR, this one. S equals theta R, SOR. So that's the third formula I'm going to provide today. If the angle's in radians, I can use this formula. All right, here we go. Ready? All right, let's take a look at number 1 here. Find the arc length. Arc length, round to the nearest hundredth. All right, so you're going in your mind right now. You're like, arc length. I have 2 formulas. One if the angle's in degrees and one if the angle's in radians. You take a peek at the diagram and you notice the angle's in radians. Oh, stop. So I'm going to give you 2 options right now because I don't want to say, darn it, you do it this way and that's the only way. I want to give you 2 options. You do what's comfortable. All right. What you could do is you could use the day 2 formula I gave you, length of an arc. But this has to be in what again? Degrees. So you could, because of all the work we did yesterday, you could turn pi over 3 into degrees like we did yesterday and use that formula. That's your call. Okay, if you don't want to memorize 2 formulas, you only want to memorize 1, take pi over 3, convert it into degrees. All right, everyone remembers doing that yesterday. And then use the day 2 formula. Or, because it's already in radians, we can use the formula I just provided, which is S equals theta R. All right, day 2, it's got to be, that formula's got to be in degrees. This one I'm showing you here, SOR, S equals theta R, angle has to be in radians. Are we making this clear? Okay, no, Rachel? You sure?
Yeah.
I got 2 here you go. Let me make this. I got 2 formulas for length of an arc. All right. Formula number 1 is the one we learned on day 2, which is the measure of an arc over 360 times pi d. And then I just gave you a second formula, which is arc length equals angle times radius. Problem is, though, this formula for length of an arc can only be used if my angle's in degrees, versus this one, my angle's in radians. So I have 2 formulas that do the same exact thing, except it's a matter of, is the central angle in degrees? Is this angle in degrees or is it in radians? And what I'm telling you guys is you can memorize both, and then whatever this is in, use the correct formula, or just memorize one of them, and you may have to convert from radians to degrees, degrees to radians like we did yesterday. Your call, though. Okay, I'm going to let you guys decide. You're smart enough to decide if you want to memorize both or just use one formula. Okay? I'm going to use both formulas in here. So see how this is in radians? I'm going to use the one that requires radians. S equals theta R. We're good? So S, what's my angle measure now? What's my angle measure? 4, what's my angle measure? Yeah, you're right. Pi over 3. And it's in radians, so that's why I'm using this formula. And what's my radius length? 4 again? 5 centimeters. So S arc length equals angle in radians times radius. And it says round to the nearest hundredth. So I go to my calculator, pi over 3 times 5. Three, what do you got for me, Spence? Nearest hundredth.
5.24.
You got it. Thank you. 5.24. Again, you want to attach the units, go ahead. All right, number 2. I look at the angle. The angle's in radians. So for me, I'm going to use the formula that requires radians. Again, if you want, take 10 pi over 9, convert it into degrees, and use the formula I used on day 2. All right, what's my angle measure in radians then? 13, angle measure in radians.
10 pi over 9.
So we go 10 pi over 9 times radius length here. 12
27.
times 27. Yep. And then plug them into my calculator. Nearest hundredth. 1. Anna.
94.25.
There you go. There's the length of my arc. Questions from you guys? All right, let's keep using this formula, but for something other than S now. All right, let's use the formula to solve for something other than S. I just made a little note here. Just make sure you guys are aware the 8 pi and the 15 pi over 7, that's the length of the arc. Okay, that's the length of the arc, not the measure. All right, that's the length. And what I'm looking for is how many degrees and radians are in the center. I want both. Okay, how many radians and how many degrees. All right, so we'll keep using the formula we've used. Theta equals, S equals theta R. SOR. But here we already know the arc length, don't we? What's the arc length? 7. What's the arc length here?
8 pi.
So everyone, 8 pi in for S equals theta is what we're solving for. That's my angle measure times a radius of 13,
16.
16. Good. All right, we got to solve for theta because theta represents the angle measure. What do I need to do on both sides? 2, maybe 6. What do I need to do on both sides here to get theta by itself?
Divide by 16.
Good, everyone. Divide by 16. Hold on, though. Don't go right to your calculator yet. Is this angle going to be in radians or degrees right now? Is this angle going to be in radians or degrees? Look at the formula we used. Is this angle in radians or degrees right now? 11? Radians. And remember what we said yesterday? What do I always like in your answer with radians? Because I don't want a whole decimal. What do I like it in? Terms of pi, right? So leave this in terms of pi. So in radians, it'll be, what's 8 over 16 reduced? 1/2. So 1 pi over 2. Everyone all right how I got there? I always like it in terms of pi. All right, now what's it in degrees? What'd you guys do yesterday? Convert? Right, you guys can convert. If I know the radians is 1 pi over 2, what'd you multiply by yesterday to convert it? Because I want that angle in degrees too. What do I multiply radians by to get to degrees? You got to look on your formula sheet. Look where it says radians in the column, and what do I multiply by? 10. What do I multiply by?
180 over.
Great job. 180 over pi. Look what happens, right? The pi's cancel. And then I'll let you guys figure out how many degrees are in that angle. When you're ready, 6. How many degrees when you're ready? 90 degrees. Perfect. It's a 90-degree angle there. All right, we okay? Everyone good? So you have 2 formulas for length of an arc. One requires radians, one requires degrees. All right, next one. Okay, could I use the formula from day 2 to find that angle? I could. This is just a little bit shorter to work with. This formula. The other one's a little bit longer, so I prefer the shorter one. What's my arc length here? Talk to me here. It's 5.
15 pi over 7.
Good job. 15 pi over 7 equals theta, my angle I'm looking for, times my radius length, 13. 5. Yep, good. How do I get that theta by itself? 2. Yep, I'll learn. 5.
You divide it by 16. Oh, what? No. You divide it by 5. I don't know what you do.
Divided by 5. And I know this is a broken record, but I'll make sure I'm driving the point home. Is this answer going to be in radians or degrees? Is this answer going to be in radians or degrees because I use that formula? 3? Radian, so I like what my answer, Spence?
Like pi here.
Darn right I do. I like pi in the answer. So what you guys need to do on your calculator right now is not 15 pi, 15 over 7 divided by 5. All right, don't put the pi in because that went into the answer already. So 15 over 7 divided by 5. And everyone's alpha y equals, you have fraction templates. Hopefully it gives you a nice fraction back too, because I don't want decimals. So 15 over 7 divided by 5. Keep the pi in your answer, not in your calculator. 11, Kelsey giving you a fraction.
3 pi over 7.
There you go, 3 pi over 7. I like that a lot. And now we go to degrees. And all it is to degrees is, oh, you know radians, convert it into degrees now. And let's go, you're going to have to round here, so I'll just tell you nearest 10th for this one. Let's go nearest 10th. So you take your 3 pi over 7, multiply it by what's on your reference sheet, 180 over pi. Pi's cancel, and you guys are rolling. Go ahead and round to the nearest 10th. When you're ready, nearest 10th.
Uh, 77.24. Oh, 1.
You got it, yep. Questions? Are we okay on both formulas? One requires degrees, one requires a radian to be plugged in to find the length of an arc. Anything you want to ask? Because now I'm going to go to word problems. Ooh, all right, let's see.
I have a question.
Sure,
Can I
yeah.
charge my calculator over there?
How about I just plug it in right here since I'm here?
Sure.
Little low on the juice, huh?
Yeah. That's very-
Anybody else need anything like a cup of lemonade? Anything else I can get you? Little scone for breakfast. Nobody, we're good. You sure? You do it all of you. Well, I'm teaching. Sure. Oh, you kill me. All right, pendulum. Do we know what a pendulum is? I should have brought up some Google search images here. Pendulum, or do we have to bring it up? Of a clock? That there, you want to, yeah, there's a great demonstration right here if anybody's looking here. Yeah, pendulum goes back and forth on the clock. All right, swings through an angle of 2.5 radians. So is this, and this, you like this like a little diagram here of my pendulum. So it goes back, once it goes back, it swings through an angle, going back and forth, right? Swings through an angle of, bless you, was that a 3-bagger? 4-bagger, are you? Wow, that's unbelievable. A 4-bagger, I may see that every 5 years. It's like a leap year. 3-baggers are like once a year, but a 4-bagger, you all right? You gonna make it? That was awesome though. That was awesome. And I'm recording too, so I can relive that. All right, put that in the date book. So it goes through an angle of 2.5 radians. It's gonna be a good day now, Charlie. and it travels through an arc of 50 centimeters. Through your arc, here's my 50, right? Now, I don't come out and say the vocabulary word we've been using. Instead, I'm asking for find the length of the pendulum. What's that the same as the vocabulary term we've been talking about? The length of the pendulum is also the what of the circle here. One, Anna?
Radius.
I'm looking for the radius. See, that's the problem with the word. I don't come out and say the vocabulary term. I turn it into a pendulum instead. But the pendulum length is the radius. So remind me again, what's this 50 here again? Put this in terms we know. What's that 50 represent? 7?
Arc length.
That's arc length. So now my mind goes, all right, arc length. I have two formulas. One that's in radians, one that's in degrees. What's the 2.5 in? 6? Radians. So probably in this problem, I want to use SOR, S equals theta R, because my angle's in radians. All right, help me out. What goes in for S? 12, arc length?
50.
50? How about my theta now? Theta is 7.
2.5.
Angle measure in radians, 2.5, and we're looking for R, the length of the pendulum. And then both sides here, what do I need to do? 5? Come on.
Divided by, wait.
I'm solving for R.
Oh, okay. Just multiply 2.5 times 20. Hold on. Oh, just divide by
Are you
2.
on another planet today?
Divide by 2.5.
Seriously.
Divide by 2.5.
Like, I'm still mesmerized, yes, by Charlie's four-bagger, but I got over it, and now I can divide by 2.5. Seven, how long is that radius?
20.
20 centimeters, yep. Everyone all right? One more for you to chew on? I think we might have to draw a little diagram here. In a circle, a central angle measures 3.5 radians. Okay, so you guys know, what a central angle is, and you can label it as 3.5 radians now. Intercepts an arc, creates an arc whose length is 24.5. So that arc it makes is 24.5. All right, hopefully nobody starts panicking. Find the diameter. Well, not right now, right? I'm not going to find the diameter right now, but you can use what given this. You can find the what given this information. 5, can't find the diameter, but I can find radius length. Yep. And the 3.5's in radians, so I can use S equals theta R. What's my S value here? 7? 24.5. Theta value? 12? 3.5. Looking for R so I can get to diameter. What are you doing on both sides to find R? 11? Divide by 3.5. I think 7, right? Length is 7. So now, help me out. How do I find the diameter length? 13. Finish it off right.
Multiply the radius.
Here you go. Questions from you guys before you start? All right, so you have two formulas now. Theta equals S equals theta R. And then the other formula from day 2, but probably on homework tonight. Depends though. Look at your angle, right? make sure you look at your angle. If it's in radians, I'm going to use today's formula. If it's in degrees, let's use the formula from day 2. All right, go ahead. You guys can get rolling. I will put the answer key up here like usual.